Now we will take the case of Young double slit. It's an experimental arrangement to produce two coherent sources. Right? We are here studying interference, the phenomena of interference. I will draw the setup. There is a source S, a point source, and the other two slits. Slits are of the kind, you can see the slit is of this kind. Right. The slit will be of the slits. The kind of slits. So a source will emit, this is a monochromatic source, so this will emit light. Light will fall on S1 and S2. The slit S1 and S2 is illuminated. We'll illuminate S1 and S2, and S1 and S2 themselves behave like a separate source. So light will emerge from S1 and S2, and suppose they are coming at point P. When you have only S1, you don't have S2, and light is coming only from S1, say the intensity is A square. Suppose from S1, the light emitted by S1 is represented by the wave equation psi1. The light coming from S1 is represented by psi1 equals to, say, A1 sine kz minus omega t, and light coming from S2 is A2 sine kz minus omega t. When they reach point P, there may be a difference in the path traveled, and hence a phase difference is developed. Right? A phase difference is developed between the two light at point P. Now this phase difference is going to decide the intensity at point P. Intensity at point P is given by intensity due to first beam, intensity of the first beam, that is psi1, intensity of the second beam plus 2a1a2 cos delta. We did this. See, light is coming from. So since light coming from S1 and S2 are ultimately light coming from S, so I can say they are coherent. The phase difference between S1 and S2 won't be a function of time. It will remain as the frequency of light coming from S1 and frequency of light coming from S2 will be same. Now this phase difference will be depending on the path difference, 2 pi by lambda into path difference. What is the path difference? Path difference will be, if I draw a normal from this point to this S2P, so if you draw this normal, this is normal, then see the distance between S1 and S2, let's call it 2D. Let S1 and S2 is 2D. You can represent it by D also. So here I am taking S1 S2 as 2D. Right, this is 2D. So the path difference S2P minus S1P would be this length. If suppose this angle is theta, this is theta, then this will also be theta, and this is 90 minus theta, so this will also be theta. So this will be, if I draw M, S2M, S2P minus S1P will be S2M, so this will be 2D sine theta. So this is 2D sine theta. Right. So for constructive interference, see different point in space, the light psi1 and psi2 are going to interfere at different point in space, and since the path difference depends on the angular position of point P, so different point having different angular positions, the path difference is going to be different, so your intensity is going to be different at different point P. So for constructive interference, those points for which the path difference 2d sine theta is n lambda, those are the points where the intensity will be maximum, because at these points your delta is 2 pi by lambda into 2d sine theta. So if 2d sine theta is n lambda, then this will be 2n pi. For these points delta is 2n pi and intensity is going to be a1 plus a2 whole square. I max, I'll call it I max. I max will be a1 plus a2 whole square, right? So the points where you can have a constructed interference is given by angular position of those points is given by n lambda by 2d, right? For destructive interference, your delta should be equal to 2n minus 1 pi or odd multiple of pi, 2d sine theta or 2d sine theta equals to this will be n minus half lambda, n minus half lambda. So the angular positions of those points where you can expect minima is given by right theta and dash is sine inverse lambda by 2d, right? Here the intensity is going to be, put delta equals to 2n minus 1 pi, so this will be a1 square plus a2 square minus 2 a1 a2, so this is a1 minus a2 ka whole square, a1 minus a2 whole square. So I max is a1 plus a2 whole square and I min is a1 minus a2 whole square. At all those points for angular positions given by this, you have the maximum intensity. All those points with angular positions given by this, you have the minimum intensity. Now if the size of slits are equal, then intensity of light coming from S1 and S2 will be equal, or the amplitudes will be equal. So if A1 is equal to A2, your I max become 4a square and I min will be 0. At all other points except this theta n and this theta n dash, your intensity is going to be 2a square plus 2a square cos delta, or this is 4a square cos square delta by 2, right? At different point the intensity is going to be 4a square cos square delta by 2. So at any point intensity will depend on what is the phase difference between the two waves which is reaching at point P from S1 and S2, right? So this is I min, this is I max. Now I will draw some fringes over here. So intensity of all the maximas, you also call it maxima, intensity of all the maximas are 4a square and intensity of all the minimas are 0. I will draw some fringes over here. This is the Young double slit. S1 and S2 are the slits. Now let's try to find out the position of maximas and minimas. Position of maximas are given by theta n equals to sine inverse, or I'll write it down here. Position of maximas are given by theta n equals to sine inverse n lambda by 2d, where n is 0, plus minus 1, plus minus 2, and so on. Theta n dash is sine inverse, where n is, I write it as 0, plus minus 1, plus minus 2, and so on, right? Those values of theta n which are positive will lie above this axis, and for negative values of theta n, those maximum will be lying below this dotted line. So the first maxima, the maxima for n equal to 0, your theta is 0, and you have the maxima at these points. These are the points. See, in plane polar coordinate, theta equal to alpha represents a line. What kind of line it represents? It represents a line. This is, if they say initial line, and this is 0 origin, then all those points which has got a angular position of alpha at all the, for all these points lying on this line, angular position is alpha. So this line is represented by theta equal to alpha. In Cartesian, the same line will be written by tan alpha x, y equal to tan alpha x. In plane polar coordinate, the line is represented by theta equal to alpha. So theta equal to alpha is not just one point, a set of points which forms a line. So for all these points, you can say all these points on this line, your intensity is going to be 4a square, and that's called central maxima. Intensity is going to be 4a square. Thereafter, for n equal to 1, you will have a minima. So I'll draw the line. For this can be, say, a minima. The minima will be formed at theta 1 dash equals to sine inverse lambda upon 40. So I have drawn minimum using blue line. Then the maximas will be the maxima will be formed at again I put n equal to 1 over here. So set of all these points represented by this is a maxima. This is maxima. Theta 1 equals to sine inverse lambda by 2d. This is the maximum. At all this point, the light reaching from S1 S2 will form the maximum intensity. Will undergo a construct interference. The intensity will be 4a square. In this case, the intensity is 0. In case of maxima, the intensity is 4a square. So all these points lying on this line, the intensity is going to be 4a square, because at all these points, if S1 S2 light is coming from S1 S2, they will undergo a construct interference. Then you have a minima. Then you have minima represented by blue line. So this can be, say, minima. This is theta 2 dash is sine inverse 3 lambda by 40. You have intensity 0. The intensity is 0 over here. Now again, you have the points of maximas. You have the maximas, theta 2, second maxima. The light coming from S1 S2 at all this point will undergo a construct interference and will have the intensity. These points will having the intensity I equal to 4a square. Then again you have the minimas, points of minimas. You have theta So this is again a point of minimum. The ray of light, beam of light coming at all this point will have a phase difference, will undergo a destructive interference, right? So if you put a screen, if I put a screen over here, place a screen S over here. Screen is, I have placed a screen. See, interference has nothing to do with the screen. Interference takes place at all these points. Here are the points of maxima, the minima, maxima, then minima, and then maxima, and then minima, right? So if I put a screen over here, the fringes will look like, this. You have the maxima at this point, 4a square, then as you move in upward direction, the intensity is falling to 0 over here. Then again it will increase to maximum at this point, and then falling to 0, and then again it is increasing at this point and falling to 0. So these are the intensity distribution. This is how intensity varies. This is how the intensity is varying as you move upward, right? In the same way, you have fringes in this direction as well. A similar fringe will lie downward also. Similar will be the fringe in downward direction also. This is 4a square, the intensity. It's a graph between intensity and this line, right? So this can be intensity axis. This can be intensity axis versus this z, this x direction, you can say. This can be the direction x. So this is how the intensity vary with as you move in upward direction, right? This is called fringe width. You can take the either this distance or you can say this distance. This is called fringe width, right? This is called fringe width. If suppose I want to get the position of these maximas on the screen, suppose the distance between the slit and the screen is, say, d is the distance between the slit and the screen, and say this is the nth maxima. So this position is, say, xn. Suppose this is xn. Then this angle will be theta n. So you can say sin theta n is n lambda by 2d. These theta n's are very small because lambda is small. So when theta n is very small, this is equivalent to or almost equal to sin theta n is almost equal to tan theta n, and tan theta n will be xn by d. So the position of nth maximum on the screen, which is at a distance of d from the slits, is given by n lambda d upon 2d. This is the position of nth maxima. N equal to 0 will give you central maxima. N equal to 1, 2, 3, 4 will give you the first, second, third, fourth, fifth maxima. N equal to minus 1, minus 2, minus 3 will give you the maximas which is below this axis. So here this is the position of nth maxima. This is the position of nth maxima. Similarly, you can get the position of minimas by putting sin theta n, or I can just put, say, this is the position of xn dash nth minima. Then xn dash is going to be, or I can write, so we want to find the position of minimas which is equivalent to xn dash by d, sorry, 1, 2d. So the position of minimas are given by, I can have the position of minimas on 2d. I put n equal to 1, I'll get the first minima. N equal to 2 will give you the second minima, and so on. Now if I want to get this distance between two minimas or distance between two maximas, that's called fringe width. We call it fringe width. Fringe width is xn minus 1. That is, if I put xn and xn minus 1, this will be lambda d by 2d. That's called the fringe width.